Welcome back to our next video in the PE Civil Engineering exam review series, where we are going to solve a truss problem. So truss problems are extremely common to the PE, and I would be highly surprised if you didn't get one. In this question, we're given a truss that is loaded with 3 applied forces at the joints. We have a 50 kip force at node C, we have a 100 kip force in the center of the truss, and then we have a 50 kip force just to the right of that. And we are asked for the force in member AB. So the question says the force in member AB is most nearly A, 100 kips compression, B, 125 kips compression, C, 167 kips in tension, and D, 167 kips in compression. Okay, so the first step with any truss problem is to solve for the reaction forces, right? And what we want to do is think about this strategically, because we don't have a lot of time on the exam, right? And so we need to use our time as efficiently as possible. So if the question is asking us for the force in member AB, we want to focus on finding the unknown reaction force AY, because EY, this roller, is not going to help us solve for the force in AB. So to do that, we're going to start down here by solving for AY, and we're going to want to take the moments about this point E, because AY will cause a moment about E, right? So we want to solve for an equation where AY is an unknown in that equation and everything else is known, right? And especially because EY, that doesn't cause a moment about point E, right? So that's why we're going to take a summation of the forces about point E. Okay, so what is causing a moment about point E? So let's say we have sum of the moments about point E, and we're going to choose a positive is clockwise summation. We're going to make sure that our moments are positive in the clockwise direction. So we're going to say that equals to 0, right? Because this is not moving. All the forces add to 0. And all right, so what is causing moment about point E? Well, we know that AY is going to cause a moment about E, and the distance away that AY is acting is 32 feet. So that moment is going to be AY times 32 feet. We'll use an apostrophe to denote feet. Then we're going to subtract this 50 kip force, right? Because that's causing a negative moment about point E. So minus 50, and the distance away is going to be equal to 24 feet times 24. Okay, and the next force that's going to cause a moment about point E is this 100 kip force acting in the center. So that's also going to be minus 100, and the distance that it acts away is 16 feet. And then finally, we're going to subtract the 50 kip force minus 50 times 8. All right, so we plug all that into our calculator, and we get 3,200 kip feet is equal to 32 AY. Therefore, AY is equal to 100 kips. Excellent. So now we know what the unknown reaction force is at AY. And so what we can do is we can take a section through this truss right here, and cut through two members, and that is going to give us an unknown force AB and an unknown force AC. So let's do that. We'll draw the joint A, right? Here's joint A. And it has a vertical component of a force, this joint, equal to 100 kips. And then we also have the force AB. And we're going to assume that that is acting in tension, right? We're going to draw it away from the joint. We always assume that forces acting away from the joint are tension. That is force AB. And that's going up at a diagonal. So we can just resolve that, right? Because we know that each horizontal piece is 8 feet and the vertical dimension is 6 feet. So we can say that that is going up 6 and 8, and that is a right triangle, right? We recognize that as a 3, 4, 5 triangle, right? 3, 4, 5, right? So that would be 10. And then we also have this horizontal force here, which is the force AC. And so remember, the problem is asking us to solve for the force AB. Well, to do that, all we have to do is sum the forces in the y direction. So sum of the forces in the y direction is equal to 0, right? And we're going to assume that up is positive. So we're going to get equals 100 kips plus, what's the vertical component of this force AB? Well, it would be this 6 over 10 plus 6 over 10 times AB. All right, so let's pull that over to the other side. So we'll get negative 100 kips is equal to 6 over 10 AB. Okay, and then that gives us that AB is equal to minus 166.67 kips. And that minus is important. Remember how we said that when we drew the force AB away from the joint A, drawing it away from the point is assuming tension, right? We're pulling on that joint. Well, what we just found is that our assumption was actually incorrect. So negative indicates compression. Compression, okay? So if we go back up to our answers, minus 167, that's compression, and that would be most nearly choice D. So D is our correct answer.